So, hello students. Tomorrow we see some more problems in stoichiometry. Okay. So, see the first one. So, what value of 0.2 N potassium permanganate, here normality is given, is required to oxidize 10 milligrams of ferrous oxalate in acidic medium. So, we know that potassium permanganate is oxidizing agent. So, ferrous oxalate is a reducing agent. So here details is given 0.2 and normal of potassium permanganate, and we need to find what value of this 0.2 and normality of potassium permanganate required to oxidize the total ferrous oxalate. How much? 10 milligrams of ferrous oxalate. So we know that if the reaction given in terms of normality or molarity, we have to follow the equalizing milli equivalence concepts. Okay, so here milli equivalence in fact actually, so we know that the MnO4 minus in acidic medium changes Mn plus 2. Okay, so getting 5 electrons. Here in fact is equal to 5. And what about ferrous oxalate? So in that ferrous oxalate there is two possibilities. Ferrous, so ferrous is changed to ferric. So this is reduction. Oxidation here ferrous oxalate, we know that FeC2O4. So ferrous oxalate means we know FeC2O4. Here Fe plus 2 becomes plus 3. C2O4 minus 2 becomes 2CO2. Okay, so here C2O4 minus 2 it changed to CO, balancing this to CO2. Now how many electrons? 2 carbons. The 2 carbon ki oxidation number here plus 3, here plus 4. So like the 2 carbons undergoes oxidation. So there is losing of 2 electrons. The total for oxidation and is equal to in fact equal 3. And we have to equalize. So therefore, milli equivalence of potassium permanganate are exactly equal to milli equivalence of ferrous oxalate FeC2O4. So what is N? We know that it is equal to N1V1 equal N2V2. Actually, there is no need of N factor because already it is normality. Normal one N factor to calculate this sum. General problems for molarity is to calculate this sum. So mainly to get normality equal molarity into N factor kabatti. So already 0.2 normality is kabatti. So directly we can write 0.2 and we have to find out the value. So what is normality of this ferrous oxalate? So here important ferrous oxalate because no information given. The molarity information level, normal information level. Here information is given in terms of mass, that is also in terms of milligrams. So milligrams is working. So in milligrams, my basis for normality find out gel. So we know what is the normality, what is the general formula for normality. So we can directly write down. So normality formula is weight by gram equivalent weight into 1000 by volume in milliliter. This is normal. So value just take as a V milliliter because there is no information given for the value of oxalate also. So substitute the values. So what is the 0.2 into its value? Next, what is the weight? Weight is it must be in grams. Already we know in the calculation of normality law. The weight by gram equivalent weight into 1000 by V milliliter. The formula weight in terms of grams is small. So but in the problem it is given only given only 10 milligrams. So that grams will convert to 10 into 10 power minus 3. This becomes grams. Okay. Weight by. So what is the molecular weight? FeC2O4. So it can be gram equivalent weight. So gram equivalent weight of this compound means we know that its molecular weight by n factor. So what is the molecular weight? Iron 56. Each carbon 24. So 64. So total become 8, 16, 11, 12, 13, 14. The total become 144. What is n factor? That is 3. That is 144 by 3. So actually here we will get cancelled. So 1000 we can write 10 power 3. Okay. So this also get cancelled. So the finally we will get V1 equal to 10 into 3 by 144 into 0.2. So then our overall calculation like this. So 50, that's 150 by 144. So overall we will get 1.04 milliliter. Here 1.04 milliliter of potassium permanganate is required to oxidize 10 milligrams of ferrous oxalate solution. Okay. So we do one more problem with somewhat different. See one more problem. So what value? Again we have to find the value of what value of 0.1 potassium dichromate. We know that potassium dichromate is also a good oxidizing agent. Is required to oxidize 50 milliliter of 0.2 m. 0.2 is given molarity cuprous sulfide it is an acid medium giving Cr plus 3 Cu plus 2 SO2. So actually this is the first problem we are doing with the Cu2s. That's why the total details are given that the formation of Cu plus 2. Because if Cu plus 2 is not given, you have to remember. So we have to identify that the cuprous becomes cupric, just like ferrous becomes ferric. Cuprous also changed to ferric. There is no other charge for it. There's one more important. It is sulfide. Here 2 coppers plus 1 plus 1. Totally plus 2. What is the sulfide means? S minus 2. Means S minus 2 in acidic medium changes to SO2. Means in this species, in this compound also, just like ferrous oxalate laga, just now in the last problem we done ferrous oxalate lo ferrous undergoes oxidation, oxalate also undergoes oxidation. In the same way, so ikkada cuprous sulfide lo cuprous undergoes oxidation just for cupric. Sulfide also undergoes oxidation for SO2. Okay, means for calculating n factor we must remember that. So now we see. So what is that potassium dichromate? What is involving ion? In the potassium dichromate we know that Cr2O7 minus 2. So the potassium dichromate becomes, we know that chromium plus 3. So I have to remember this. In this problem it is given. So 2 chromiums, 2. So what is the oxidation number of chromium here? If you calculate it's 2x minus 14 minus 2. So 2 chromiums ki how much you will get? Sorry. For 2 chromiums it is equal to 12. So here we say 1 chromium plus 3. 2 chromiums means plus 3. So here 2x equal we can write plus 6. Okay, x calculate x is than double because for 2 carbons covered. Okay, so 2x equal to 12. From 12 to its oxidation number changed to plus 6 means what is the number of electrons? Means each carbon actually perfect just x equals to plus 6. So here would x equals 6, but how? Sorry, x equals 3. but two chromiums are oxidizing. One chromium from +6 to +3, other chromium also changed from +6 to +3. The total 3 electrons. Decreasing oxidation means gaining of electron. Total 6 electrons. Means n factor here. N factor equals 6 for this. Next here important one, the calculating the n factor of oxidation of Cu2s. So in the Cu2s we know that what is the copper position? Cu +1, 2 coppers are there, they become Cu +2 by losing 2 electrons. Each copper get +1, 2, +2. Second copper, each copper +1, 2, +2. Second copper also +1, 2, +2. Total losing 2 electrons. Then what is the one more change? The sulfide. Sulfide is also given change into SO2. Now one sulfur, one sulfur. So we are not writing about oxygen. Just any change on the other one discuss system. Because sulfur oxidation number is how much? So calculate this again. We will get that is a +4 of 7. X minus 4 equals 0, x equals 4. So your oxidation number -2 to +4. When it is possible? By losing 6 electrons. Okay, -2 to +4. So what is the difference? 6 electrons. So for oxidation, n factor equals 6. So now we know that for it's a complete reaction. We need to find out the value. Molarity is also given. Both polarity is given. We know that we calculated the n factor. So now one first value find out cheyalante. We have to equalize the milli equivalence of both compounds. So therefore we can write milli equivalence of potassium dichromate is exactly equal to milli equivalence of Cu2s. N1V1 equals N2V2. So what is the given for potassium dichromate? The potassium dichromate is given molarity. So molarity we are writing M into V1. It's also molarity into normality. So n factor into its value. Why it's smaller? So we can write M1 N1. This shows some difference. So what is the molarity of potassium dichromate is given 0.1. What is n factor for it? Its n factor is, we know it's the 6. Next, what is the value? We have to find the value. What is M2? So how much molarity is given for it? 0.2 M. What is n factor for it? 8. So how much value is given in the problem? 50 milliliter of cuprous sulfide. Simply we have to find V1. So here, so one point get cancelled. So finally we will get nearly 133. So approximately 133.33 validity. (133 milliliter of potassium dichromate is required to oxidize the total amount of cuprous sulfide. Okay. See another problem. So the what weight of, so here, so in maximum problems here, the question is find the value, but in this question it is we have to find the weight of the compound. So what weight of potassium permanganate is required to react completely with 500 milliliter of 0.4 m CuS. So here CuS means it is cupric sulfide. Cupric sulfide means so what you guess is oxidation. So the potassium permanganate is a oxidizing agent, itself it is reduced. So automatically CuS itself it is oxidized, it works as a reducing agent. Itself it is oxidized, we know that. So in the last problem cuprous sulfide. Cuprous sulfide like cuprous cupric oxidize and the sulfide SO2 oxidize and you can already see sulfide. So sulfide already we know that it oxidizes to SO2. But here it is Cu plus 2. Cu plus 2 ki cupric oxidize avadam there is no choice. ఎట్లయితే మనకి ferrous sulfate ferric sulfate లో just like ఇంకో example what we done ferrous oxalate ferric oxalate. Now ferrous oxalate అన్నప్పుడు మనకి ferrous become ferric, oxalate become CO2. So both species undergoes oxidation. But in the ferric sulfate, ferric already plus the oxidation avadam choice లేదు అక్కడ. So oxalate అప్పుడే oxidize అయింది. In the same way cuprous sulfide in last problem చేసిన cuprous sulfide లో Cu plus cupric అయింది, sulfide SO2 అయింది. In the same way సో ఇక్కడ cupric ఉంది ఆల్రెడీ. సో cupric ఉంది కాబట్టి ఇది ఆక్సిడైజ్ అవ్వడానికి ఛాయిస్ లేదు. ఇక్కడ సల్ఫైడ్ ఒక్కటే ఆక్సిడైజ్ అవుతుంది. సో సల్ఫైడ్ ఇన్ acidic medium oxidizes to which compound? That is SO2. So what is the N factor? We know that MnO4 minus. So we know already it's oxidation number plus 7. In acidic medium, MnO4 minus changes to this. What is the N factor? N factor equal 5. We know that. Next, what about cuprous sulfide? So cuprous sulfide lo only which part undergoes oxidation? Only sulfide because CuS low S minus 2, Cu plus 2. So this Cu plus 2 it oxidizes out and there is no other possibility. So the maximum oxidation number of oxidation state of copper is plus 2 kabatti only S minus 2. We know S minus 2 is oxidized to SO2. So change is 6 electrons. How you got 6 electron means the sulfur oxidation number 4 here sulfur oxidation number minus 2. So minus 2 to 4 means how it is possible? So by losing of 6 electrons. So what is the N factor? N factor is equal to 6. So what is the we have to complete reaction. We have to do it for complete reaction. So we can write the milli equivalence of CuS is exactly equal to milli equivalence of potassium permanganate. Okay, so actually మనం weight of potassium permanganate find out చేయాలి కాబట్టి right side రాస్తాం. So we can write any side, no point about it. So milli equivalence here normality into so N1V1 N2V2. So normality of this compound, normality again it is given only in molarity. So molarity is the molarity into N factor into value. For this also actually the molarity will be normality will be. So there is nothing information is given for potassium permanganate. Okay, just we have to find out the weight. So actually we can expand this normality form, that is weight by gram equivalent weight to 1000 by V milliliters. Value also we are taking as V milliliters. Same, ikkada value same thing. For example, if take here 100 milliliters, here also we have take 100 milliliters. Okay. So what is our target? Our target is to calculate the weight of potassium permanganate. So what is the molarity of cupric sulfide? It is given 0.4 m. What is N factor? Another 6. We have to find the value. What is the weight? So his value is given. So I think it is given 500 milliliters. Okay. So it's given 500 milliliter for cupric sulfide. So what is the weight? We have to find the weight of that. Gram equivalent weight means molecular weight by N factor. So N factor for potassium permanganate is 5. So it is 10 cube. So VML get cancelled. So finally, what is the weight of KMnO4? So you can write 0.4 into 6 into just some cross multiplication. Okay, again 158. So final calculation will get is 5. Okay, by 10 by 100. So again 0.04. So on total calculation we will get approximately 38. So that 38 potassium permanganate is required. So 38 grams of potassium permanganate is required. So you can write the total step plan. Okay, see the last problem. So it's very important and it's totally different when compared to the starting problems. So see, as first understand the total problem. Okay. So in a chrome plating plant, so means it is an industry. So chromium coating is there, that is called chrome plating industry. In that industry, the chromate ions are present in wastewater. So the chromate ions means CrO4 minus is called chromate ions are reduced to insoluble chromium hydroxide. Means here information is given that chromate are converting into chromium hydroxide by, so they are reduced to chromium hydroxide by dithionate ion H2O4 minus 2. Okay, dithionate H2O4 minus 2. Have to remember from now onwards H2O4 minus 2 is the dithionate. Okay, in basic medium. So what the reaction also given. So CrO4 minus 2 it changed to chromium hydroxide. So H2O4 minus 2 it changed to SO3 minus 2 ion. Okay. So we have to, what is the exact problem is, so 10 liters of water, actually 10 liters of water now. So how much is there? That water contains CrO4 minus 2 ions. Okay. So this 10 liters of wastewater, it need 522 grams of sodium dithionate. Actually this is sodium dithionate. Sodium dithionate మన ion లో కన్వర్ట్ చేస్తే దీన్ని సోడియం ions, this is dithionate ion. సో ఆల్ మనకు తెలుసు వేస్ట్ వాటర్ లో ఏం డిజాల్వ్ అయింది, వేస్ట్ వాటర్ is containing this chromate ions. సో ఆల్రెడీ మనకు తెలుసు chromate ions are reduced to chromium hydroxide. So reduce our take, so some reducing agent should be there. So what is that reducing agent? Sodium dithionate. అయితే so in how much amount of what is taken? 10 liter of that waste water is taken. ఆ 10 liter of waste water లో ఏంది, some amount of chromate ions ఉన్నాయి. సో ఎన్ని ions ఉన్నాయంటే, సో దీనికి ఇన్ఫర్మేషన్ మనకి ఇండైరెక్ట్ గా ఇచ్చింది. సో ఆ 10 liters of waste water లో ఉన్న chromate ion రెడ్యూస్ చేయాలంటే 522 grams of sodium dithionate is required. So I have to find, so calculate the normality and molarity of chromate ions. అంటే ఇప్పుడు వేస్ట్ వాటర్ లో ఉన్న chromate ions ఫైండ్ అవుట్ చేయాలి. జస్ట్ మనకి ఇచ్చే ఇన్ఫర్మేషన్ ఏంటంటే, సో 10 లీటర్ ఆఫ్ వాటర్ లో ఉన్న chromate ion రెడ్యూస్ చేయాలంటే 522 grams of sodium dithionate యూజ్ అవుతుంది. సో దాన్ని నార్మాలిటీ ఫైండ్ అవుట్ చేయాలి. సో తర్వాత మొలారిటీ, నెక్స్ట్ పార్ట్స్ పర్ మిలియన్. సో యాక్చువల్గా మనకి ఫస్ట్ నార్మాలిటీ ఫైండ్ అవుట్ చేయాలి. దట్ ఇస్ ద బేసిక్ టార్గెట్. ఓకే, సో I'm totally roughing this problem. So I have to write. problem is in so the sodium dithionate is changed to what? It is given SO3 minus 2. What is the sulfur oxidation number? So 2x. So for balancing, we are writing it as 2. We know that so sulfur complex sulfur atoms compulsory the balance of it. Okay. So here x equal to each sulfur is having plus 3 oxidation state here. Here each sulfur is having x minus 6 equals minus 2 x equal to plus 6 4. So plus 3 2 plus 4. So like that 2 sulfurs are present. They are changed from plus 3 to plus 4 plus 3 to plus 4. When it is possible? By losing totally 2 electrons. Means what is the n factor? N factor is equal to 2. So then what is the other change? It reduces which compound? Chromate. It reduces the chromate into chromium hydroxide. CrOH taken 3. So one chromium. So already it is balanced. So here chromium oxidation number, if you calculate overall charge is minus 2. So x equals 6. Here if you calculate x OH always power minus 1. So the one chromium is changed to plus 6 to plus 3, or it is reduced. So by taking how many electrons? 3 electrons. Here n factor is equal to 3. So it is reduced, it is oxidized, it is reduced by S2O4 minus 2. So for the further calculation, we calculated the n factor. So just remember n factor of S2O4 minus 2 is 2 and CrO4 minus 2 is 3. So here important point. So actually in terms of molarity, so ఏదో ఒకదానికి మనకి 2 compounds మన reacting species to each other. సో ఏదో ఒక స్పీసీస్ కి మొలారిటీ ఇచ్చిన మనం సెకండ్ దానికి వెయిట్ ఫైండ్ అవుట్ చేయొచ్చు, నార్మాలిటీ ఫైండ్ అవుట్ చేయొచ్చు, వాల్యూ ఫైండ్ అవుట్ చేయొచ్చు. బట్ ఇట్ ఈస్ నో మొలారిటీ ఈస్ గివెన్ ఫర్ ఎనీ కాంపౌండ్. ఇచ్చిన క్రోమేటాన్స్ కి there is no molarity, normality, value is given. Next, there is no molarity, normality information given for sodium dithionate. So molarity model lo unte manam milli equivalence equal చేస్తాం. Milli equivalence of chromate equal milli equivalence of dithionate, but it is not given. So milli equivalence కాకుండా మనకి what is the other technique? We can compare the equivalence. Okay, equivalence. So just like in terms of moles, in terms of moles లో ఉన్నప్పుడు చేసే problem, you have to follow that. So what are the two compounds? The two compounds are we can write number of gram equivalents. Number of gram equivalents of S2O4 minus 2 are exactly equal to number of gram equivalents of, so combine these numbers రాసేస్తున్నాం. The number of gram equivalents of S2O4 minus 2 are exactly equal to CrO4 minus 2. So gram equivalence equals gram equivalence. So what is the gram equivalence formula? Gram equivalence formula equals is weight by equivalent weight. Weight by gram equivalent weight. So then the equivalent weights because we don't know about the weight. So దీన్ని కూడా మనం weight by gram equivalent లో కన్వర్ట్ చేయొచ్చు. బట్ దీనికి మనకి we don't know any information. So chromate and మనకి weight information కూడా లేదు. So కాబట్టి just leave it as a equivalent. Equivalence. Okay. So weight, how much weight is given? It is given 522 grams. Gram equivalent weight means gram molecular weight by n factor. So what is the molecular weight of Na2S2O4? So 23 is 46. 64, so 64. So 5 will get 10, 14, 7, 11. It's 174 by 2. Okay, molecular weight is 174 we are getting. What is n factor below that? 2 n factor equal 2. So that is the equivalence. So on overall this calculation we will get so equivalence of CrO4 minus 2. So on this overall calculation, let's try to calculate it. So on overall this calculation we will get 6. So 6 equivalence of S2O4 minus 2 is equal to nothing but equivalence of CrO4 minus 2. So ఇక్కడ మనకి జస్ట్ డైథయోనైడ్ గురించి మనకి అవసరం లేదు. సో డైథయోనైడ్ మనకి ఇచ్చిన డీటెయిల్స్ ఏంటంటే 522 గ్రామ్స్. సో దాన్ని బేస్ చేసుకొని దాని మిల్లీ ఈక్వివలెన్స్ ఫైండ్ అవుట్ చేసినాం. గ్రామ్ ఈక్వివలెన్స్ ఫైండ్ అవుట్ చేసినాం. ఇప్పుడు అదే గ్రామ్ ఈక్వివలెన్స్ దేనికి అప్లై చేయొచ్చు మనం? దే ఆర్ ఎగ్జాక్ట్లీ ఈక్వల్ టు ద గ్రామ్ ఈక్వివలెన్స్ ఆఫ్ CrO4 minus 2. Okay, so therefore number of gram equivalents of CrO4 minus 2 is equal to 6. So actually మనకి this 522 grams of S2O4 minus 2 use అయింది. ఈ 522 grams of S2O4 minus 2 దేనికి యూజ్ అయింది? టు రెడ్యూస్ ద CrO4 minus 2. కాబట్టి దాని గ్రామ్ ఈక్వలెన్స్ దీని గ్రామ్ ఈక్వలెన్స్ ఈక్వల్ చేసినాం. దానికి ఇన్ఫర్మేషన్ వస్తే 6. సో కాబట్టి దీనికి కూడా 6. బట్ మనం ఫైండ్ అవుట్ చేయాల్సింది కాన్సన్ట్రేషన్ ఇన్ నార్మాలిటీ. ఓకే, సో వాట్ ఈస్ కెన్ యూ డిఫైన్ ద నార్మాలిటీ డెఫినేషన్? So the number of gram equivalents of a solute, the number of gram equivalents of a solute present in 1 liter of a solution. A gram equivalents ni 1 liter ki calculate cheste, that is called nothing but normality. So ikkada manaki 6 equivalents vachindi. Ee total reaction lo participate in a CrO4 minus 2 equivalents ennante 6 equivalents. But తీసుకున్న total water in the solution 10 liter solution ki 6 equivalents వచ్చింది. But according to the normality definition, the number of gram equivalents present in 1 liter of solution, 1 liter calculate that. So equivalence of CrO4 minus 2 in 10 liter equal to 6. So the number of gram equivalents of CrO4 minus 2. So it is the main point here. So 10 liter మనం ఇప్పటిదాకా క్యాలిక్యులేట్ చేసింది. So what about for 1 liter? 1 liter becomes how much? So that is equal to 0.7 equivalents per liter. So equivalents per liter nothing but ఏంటిది? నార్మాలిటీ కదా. So therefore యాక్చువల్గా మనం ఇక్కడ చేస్తుంది ఇండైరెక్ట్గా నార్మాలిటీ క్యాలిక్యులేట్ చేసినాం. నార్మాలిటీ డెఫినేషన్ చేస్తాం. I said that the number of gram equivalents present in 1 liter. సో 10 లీటర్స్కి వచ్చింది 1 లీటర్ క్యాలిక్యులేట్ చేసినాం. అంటే 1 లీటర్లో ఎన్ని గ్రామ్ ఈక్వివలెన్స్ ఆఫ్ CrO4 minus 2 ఉంది? 0.6. సో therefore normality is equal to 0.6. So according to definition. According to definition of normality, we can understand it. So normality 0.6. What about molarity? What is the relation between normality equal to molarity into n factors? What is the molarity? Molarity normality by. So what is the n factor for this compound we are adding? CrO4 minus 2. So n factor is equal to 3. This is 0.3 molarity. Molarity 0.3. So normality, that is 0.6. Okay. Next, it is also given. So problem is not completed. So మన problem like ppm parts per million అడిగింది. So parts per million మనం find out చేయాలంటే we have to do some more. So we have to find the concentration in ppm. So what is the ppm find out challenge? Concentration in parts per million. So equal to weight of sodium chromate. So actually మనకి I know to CrO4. By what is the total value? It's a 10 liter. Okay, so 10 liters. So 10 liters means milligrams. We can say this. So it is given 10 liters, but we got the molarity for 1 liter. So 1 liter covered. We just take 1000 milliliter or 10 power 6. So parts per million. Here important is why we are taking 1000 means what is the ppm formula means weight of that particular solute, weight of that particular species by total volume into 10 power 6. Normal percentage ki 100 calculate chestam. ఇక్కడ very low concentration ki manam million ki calculate chestam. Million means ఇక్కడ 10 power 6. So actually we don't know the weight of sodium chromate. Sodium chromate weight is not given. Actually sodium chromate weight find out cheyalante with the help of molarity we can do it. So what is the molarity? General formula molarity weight by gram molecular weight into 1 by V liters, volume in liters. Okay. So liters 1 liter will be calculated for 1 liter. So because already we know the molarity, how much molarity was there? 0.2. So 0.2 equals weight by what is the gram molecular weight of sodium chromate? Sodium chromate gram molecular weight again. And into CrO4. So 46, 52, 64. Overall calculations 12. So finally we get 160 gram molecule 162. So 1 by 1, therefore weight equal we will get 0.2 162, that is 32.4 grams per liter. Okay, just weight కాబట్టి మనకి 32.4 grams. దీని equation 1 లో సబ్స్టిట్యూట్ చేయండి. Okay, so here we get 400 ppm. Means so actually generally for very low concentration we use ppm, but here it is given we got answer 32,400 ppm. So 32,400 ppm and it is just nothing but 32.4 grams in 1 liter. Okay, so try to practice 2 or 3 times without seeing the notes. Just write the question and practice it without seeing. Okay, tomorrow we see some more problems.